Alrighty guys, so in our notebook under our new chapter here, we hopefully have all of our shortcuts now that we understand. Like if I can show that three sides of one triangle are congruent of another, then I can say the two triangles are congruent. And so we have our side, angle, side, angle, side, angle, 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 side, the ones that do not work. And then this one that we haven't talked about yet, which I know is in our maze, but don't worry about it. Like it's going to be okay. Okay, so we're going to add to our notebook, and you may already have some of this because maybe we did it in class together. So I'm going to timestamp this for you guys in the assignment so that you can jump ahead if you need to. So starting on page 39, really through page 44, we're going to be talking about proof hints and like a flowchart proof. So I'm just going to label this proving triangles congruent, hints, and practice. Okay, so again, like we may have talked about some of this already in class, so this might be a repeat. You can skip ahead if you need to. So the first thing I want to look at is actually on page 39. So I really like to do triangle proofs by using what's called a flowchart proof. Okay, and everybody always makes fun of how my flowchart proof looks, but I think it really works, and it helps me so much. Like I like it so much better than a two-column proof just because I can kind of work backwards, which is really nice. Okay, so essentially when we're trying to figure out how we're proving two triangles congruent, like using side, 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 angle, side, angle, side, angle, or angle, angle, side, you're really just looking at the tick marks. Okay, so once you've determined that, inside of this bullet right here, you are going to put your shortcut. So shortcut can be something like side, 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 angle, side, angle, side, angle, 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 side, and eventually when we get to it, HL. Okay, so you're going to be looking at the tick marks to determine how they are congruent, and you'll write that shortcut right in the box. Now on this little line right here, you're going to say which triangles are congruent. So you're going to put your congruence statement, which, depending on what triangles you have, it's really just going to look like triangle, congruent to triangle, and we want to make sure that we write them in the correct order. So that's why I like this, because we can kind of find the reason that they are congruent and then work our way backwards. So then the next thing that we do on these lines here and in these rectangles is we say exactly which three things are congruent. So like on the lines themselves, so like on these lines right here, we put either sides or angles are congruent. So like literally you're saying, you know, side AB is congruent to side CD or something like that. Or an angle is congruent to an angle. So that's what you're going to be putting on the line here. So angle congruent to angles, or sides congruent to sides. That's the only thing that you could put on this line. And so if we had something written like this, this would imply that it was angle, side, angle. But it could be any combination of those. But that's the only thing that you'll write on those lines there. Now, in the boxes over here, you're going to explain why those things are equal. So they might be equal because it was given to you. They might be equal for some other reason, and that's what we're going to look at on the hints page. So in the boxes, and these may or may not need to be there. So I'm going to put optional, but in quotations, because like it's not really optional. It's just like you might use those boxes if you have to explain why something is equal. You may not need them if they just tell you that they're equal. Okay, not optionally, just optional. But explain why angles or sides are congruent. And again, we're going to go over the why stuff might be congruent in our hints on the next few pages. Now, last but not least, back here, you won't put anything on the lines in this last little space. But in those circles, you're going to ask the question again, why? Like, how do you know that something was equal here? How do you know this? And at that point, you're either saying because it was circle G given to you, or circle P in the picture, you could see that you had something that was equal, like maybe they gave you some tick marks already. So that's always going to be what goes in your circle, which is why you might not need these rectangles here, because if it's just given to you that two angles are equal, if they say in the given statement that angle 1 is congruent to angle 2, well, you don't need to explain why. You just need to say that it's circle G given. And I think this will become more clear when we do a few examples. Okay, so onto our hints page. So different things that we're going to want to look for to help us figure out if triangles are congruent or not is to really label up our picture. It's so important to add those tick marks and rainbows on angles to show if stuff is congruent or not. So one of the first ones that I want to talk about with you are things that you're going to get from the picture itself. So it doesn't have to be written out specifically that you know these things are equal. You can just look at the picture and know that it is. So the first thing that we have, we actually talked about the reflexive property before, and I kind of said, like, it's so weird, like the reflexive property says that this angle is equal to itself, or this side is equal to itself, which didn't really make much sense at the time, but now I think it does make sense, because in this picture here, I can see that I have some angles equal, but this side right here that is shared between the two triangles is really on both triangles, and it's the same because they're like sharing it. So I really can add a tick mark here, and on my line, like in my flowchart proof, I could say that PR is congruent to PR by the reflexive property. So like on your little, I like to call them a tentacle. Like this thing to me looks like a squid, and then we got 3 little tentacles coming out. So on your little tentacle, you would have PR is congruent to PR, and I would know so because of the reflexive property. And I can tell that I have a reflexive property thing going on because of the circle P picture. Okay, so this is always like a shared side, or could be a shared angle. That's like less frequent, but could happen. So again, in this picture here, I have this shared side, and so because HF is on this like top triangle and on the bottom triangle, they're the same on both, and so I could use 3 tick marks to show that like HF is congruent to itself. So again, I can say HF is congruent to HF, and on my little squid tentacle, you would be writing the same thing. And when I go back on that rectangle and say why, it's because of the reflexive property. And I know that I have that because I looked at my circle P picture. Okay. Now, another thing that you can get by just looking at the picture is vertical angles. And we can tell that we have vertical angles if we have 2 lines crossing each other, and then the angles across from them are vertical, And we also know that vertical angles are equal. That was actually a theorem that we talked about a while ago. So in this picture here, I can see that these angles are already equal, and then these sides are. So I need a third thing if I want to prove the triangle is congruent. And looking at this picture, I notice that these two angles here are vertical, therefore they are equal. Then I could actually prove that this triangle is congruent by angle, side, angle. And just as a quick aside, like this one was also angle, side, angle. And this one was side, side, side. Just as a little practice there. Now again, by looking at this picture here, I can tell that angle WXV would be congruent to angle YXZ. And again, I need to name these very specifically. And I can't just call it X because there's lots of angles at X, so I got to use 3 letters. And I could do that because, so like in my rectangle box that would be connected to this line here, I can say those things are equal by the vertical angles theorem. And I know that I have vertical angles because I saw them in my circle P picture. Now, similarly, we would do that here. So again, I have 2 lines crossing. So at E, I can mark that those angles are congruent. I could then prove that this triangle is congruent by side, angle, side. And so I would write on my line, angle DEB is congruent to angle. Now I went across the 1 ticky and then the 2 ticky. So you got to do the same thing here, angle AEC. And again, this would be the same thing that I would write in my flowchart proof. Okay, so another hint that we can look for, or more things that we can look for, are considered definitions. So these are some definitions that we have that we've talked about in the past, and they show up a lot to help us prove that triangles are congruent. So one definition that we've talked about before is the definition of a midpoint. Now, the only way you could use definition of a midpoint as a reason that some sides are equal is if they told it to you. So they must literally say these words in the given. So like this little sentence right here would have to be in the given statement. If it's not, you can't say stuff about midpoint. Even if it looks like it might be a midpoint. You don't know. They didn't tell you, so you can't do that. But if they do tell you that E is the midpoint of KW, midpoint by definition splits a side equally in half. And so I could put tick marks on either side of E on those lines there. And we could say that KE is congruent to WE. And again, I would know so. So like if we're thinking about what our little squid tentacle would look like, we'd have like our side right here, and then in the rectangle, sorry, I'm like off the screen. Which way do I want it? That's the way I want it. In the rectangle, to explain why, I would say by definition of midpoint, oh my gosh, I made my rectangle too small. And then I would know that I had a midpoint because it would have to be in the circle G given. So similarly here, if they tell me that D is the midpoint of MT, I could mark on my picture that those two sides are congruent because midpoint split something equally in half. So I could say that MD is congruent to DT, again, making sure that we're traveling the same way. And then my rectangle would look the same. So by definition of midpoint, and I know I have one because it was given to me. Now, another definition that we talked about was an angle bisector. Actually, we talked about segment bisectors too, which we're going to maybe add that in the middle here. So an angle bisector is something that we could look for, but again, it has to be in the given. Like it has to be written out specifically for you that the angle was bisected. Now, bisect means to cut in half. So again, in the given, if it said to you AD is the angle bisector of BAC, that means that this line is cutting that angle equally in half. So I can add rainbows to my picture to show that this side of the angle is the same as that side of the angle. So like if it was 100 degrees, each side would be 50. So therefore congruent, really. So then on my little tentacle, I would be saying that angle BAD is congruent to angle CAD. And then in the rectangle itself, I would have to say those two angles I know are equal by definition of an angle bisector. And I knew I had an angle bisector only because it was in the circle G given. So that's kind of annoying to write. Similarly with the vertical angle. So it's nice when they put little digits in there for me. And if they said to you that DC is bisecting ACB, so we're cutting this angle up here in half, I would then know that angle 1 and angle 2 are the same. And so I could write angle 1 is congruent to angle 2. It's so much nicer when we put little digits on there. And again, for the same reason. By definition of an angle bisector, and I would only know that I had one because it was in the circle G given. Now, I did say I wanted to add one here, and I do. We also talked about perpendicular stuff. So we might have a perpendicular bisector. And a perpendicular bisector is actually really nice. I thought I had, well, don't know where it is, but that's okay. I'm talking to myself. Don't worry about me. A perpendicular bisector is nice because it actually gives you two things. So like you can add two little squid tentacles to your flowchart proof, because this is actually saying two things to you. I'm cutting something in half, because that's what bisector is, but I'm also perpendicular at that spot, which means I have some 90-degree angles. So again, you kind of get two little tentacle legs here. You would say that two angles are congruent to each other, and you would know so because perpendicular makes them both right angles, and right angles are congruent. And I knew that I had right angles because I know the definition of perpendicular. And I knew that something was perpendicular because it was given to me. It would have to be told to you in the given that something is a perpendicular bisector. So this just shows you, you don't necessarily have to just have one rectangle on your little squid tentacle. You could have two. Now the other tentacle that you give with just this one word, like this one phrase, if they say to you that CD is the perpendicular bisector of something, you get that two angles are right angles by definition of perpendicular, so that's good. But you also, the bisector part means that it cuts some sides in half. And so you'd also be able to say that a side is congruent to a side because you understand the definition of bisector, and you knew that you had one because it was circle G given to you. Lots of info. I'm going to timestamp it all so that you can hop around. Hopefully that helps. Now, last but not least, oh no, I'm sorry, I have one more after this. Another hints page is if stuff is parallel. So if they tell you that things are parallel, like we got some parallel lines here. Actually, we might not need to do all of the parallel line examples because these are all pretty similar. But if we have parallel lines, that's actually super nice because you get all of those angle pairs that we talked about before. So we could say that corresponding angles are congruent, or alternate interior angles are congruent. So for example, if they tell me that AB is parallel to CD, whenever I'm parallel, I have to have one transversal. So you got to make a choice in this case. And so maybe I go with transversal BD. I could go with the other one, but if I pick this one, I'm pretty sure that right here, and oh no, not there. Oh my God. And right there, those two are touching the parallel line and transversal, and they're creating alternate interior angles. And so since the lines are parallel, we can say that those angles are congruent to each other. So on my little squid tentacle, I could say angle B is congruent to angle D, and I can just call them that because there's no confusion. Like there's not multiple angles at B. And in my rectangle, I would know that those are congruent because they are alternate interior angles. And those are only congruent when lines are parallel. And I knew that I had parallel lines, oh my goodness, because it was circle G given to me. Running out of space. Okay. Another example of that over here. Now we could get these two because I could pick the other transversal. But in this one, if they tell me that QN is parallel to PM, again, I could pick lots of different transversals here. I guess lots is an over-exaggeration. I could pick two. I could pick this one because that is going through the parallel lines. And I can pick this one. I wouldn't want to pick that one because like it doesn't touch the other triangle. So this is actually, I think, not a great one either because this is only on that triangle. And you want one that's going to touch both triangles. So I think we want this one because this transversal will eventually get onto both triangles. This one wouldn't. It's only on this first triangle. And this one wouldn't because it's only on that second triangle. So you really want it to go through both triangles. And that's cool. It actually works out really nicely because on our parallel lines, I get this angle here and that angle there, which is a pair of corresponding angles. And corresponding angles are congruent. So I could say angle N is congruent to angle, really I should call it PML, because there's lots of angles at M. And I would know that those are congruent because they are corresponding angles, and corresponding angles are congruent. However, they are only congruent if I have parallel lines, which I did. And I knew that I did because it was given to me. So again, this is one of those where you're going to have two rectangles coming off your tentacle because you need to name the pair and you need to know that the lines are parallel. Okay, so down here, AB is parallel to CD. Now again, I want to pick a transversal that's going to touch both my triangles, and to really, like I could pick this one, but it's only on that top triangle, and I could pick that one, but it's only on the bottom, so I think this is really the one that we want. And these ones can be sneaky because like we're going to get alternate interior angles again, but we don't want these ones because like that's outside the triangle. We want the ones that are contained within the triangle. So that would be this one here and that one there. And again, this would be like the same little tentacle as that first one. So maybe we can skip the tentacle stuff. And then similarly here, now these lines are actually the horizontal looking ones. So BC is parallel to AD, but I still want to pick that same middle transversal because it's on both triangles. However, so I think it's easier to see the alternate interior angles on this one, but like these ones I don't want to pick because they go outside of the triangle. Like I have to connect the transversal to that parallel line, and it goes outside of the triangle, and you don't want that. So I really need to pick this one and that one. So I know those pictures are kind of confusing to look at. And then the last hint page that I have for you is where I maybe share a side or an angle. Now this is the reflexive property again. So reflexive property. But sometimes finding that shared stuff is tricky. So in number 1 here, the thing that both the triangles are sharing, so if I take a look at this triangle here and this triangle here, they are completely sharing side BC. And so I would say like BC is congruent to BC by the reflexive property because it's in my picture. We're not going to do 3 and 4. Like, I just don't, no, just no. Don't worry about them. But number 2 is actually a really good one because if I take a look at, there's a lot of triangles I could look at here. But if I look at this one and I look at this one, so kind of the bigger triangles, they are sharing like parts of a side, but they're not fully sharing that side, so that's not great. However, they are fully sharing this angle up here, which I don't know, I think is supposed to be the letter D we're going to go with. But they're fully overlapping on that angle, so that's an example of the reflexive property working for an angle. And so we could say that angle D is congruent to angle D for like the blue triangle and the yellow triangle. So that's kind of a fun thing. Anyways, those are all of our hints. And then in here, we got a bunch of proofs. So this one I'm going to post in a separate video.